Actuator and applications. As you can see here on the screen, the smoke control system is simply used to limit the migration of smoke in a building that would be created by a fire. So essentially what we want to do is contain the smoke to the smallest portion of the building proper as possible and provide safe means of egress for the occupants to exit the building. Our agenda is going to include smoke control systems. There are two types, dedicated and non-dedicated. The different smoke control strategies, we will include containment, an engineered smoke control system, then the fire smoke damper actuator itself, basically the hardware that opens and closes the damper, fire dampers, which are different than fire smoke combination dampers, smoke dampers, as I referenced, combination fire smoke dampers, application solutions from Belimo, the actuators we provide for fire smoke damper applications, proportional systems, some information on our good friends from Underwriters Laboratories, and retrofit applications as well. So NFPA standard for smoke control systems. There are two types of systems, as I mentioned in the agenda. A dedicated system that is simply used for the purpose of providing smoke control. So this is a standalone system integrated with fire alarm and smoke detectors, and its intent is to move or migrate smoke out of the building or contain smoke in different parts of the building. In some cases, we will see this in a stairwell pressurization application. And then we have the non-dedicated system. And basically, a non-dedicated systems use components of other systems in the building. Specifically, the HVAC system is most common. And this changes from a normal, say, HVAC application to a smoke control mode when there's fire detected in the building. With HVAC systems that are used also as non-dedicated smoke control systems, some things have to be taken into consideration, like the motor factor, service factor, and number of belts on a fan motor, the temperature rating of that fan capacity for the smoke control criteria as well, and of course, since we are a life safety system, these non-dedicated systems have to be on emergency power. So the two most common smoke control strategies are containment, which is about 85% of the market, and its intention is to maintain compartmentation. Duct detectors or heat detectors will close dampers to prevent smoke from migrating from one room to the other or into different parts of the building. And then a smaller, about 15% of the market, is the engineered smoke control system. And this is something where dampers can be overridden by the firefighter smoke control system, maybe to ventilate, to pressurize. There's an override option here with the engineered smoke control system that allows the firefighters to manipulate the dampers in the building, to contain, move, exhaust, do what needs to be done to make sure the space is free of smoke and there's a safe means of egress for the occupants from the building. So the first and most common type of smoke control system I referenced is containment. And here we see a very basic example of a containment style fire smoke damper actuator assembly with a duct detector and a motor for the damper itself. And what happens in containment is, say we have a ductwork that spans multiple rooms, for instance in an office building, and a fire breaks out in one room that the ductwork feeds. Smoke can spread through that ductwork, as well as the fire can spread through the ductwork into other areas of the building. What we do with the containment fire smoke damper application is we simply close the dampers associated with the space that has the fire and smoke condition in it, and that prevents the fire and smoke from spreading to other areas in the building or other rooms served by that common ductwork. A typical way to control this is either by a local smoke detector, local duct detector that is located at the fire smoke damper assembly, or this can also be associated with a fire alarm panel, and that fire alarm panel will make and break a local relay to open and close the damper associated with the fire smoke damper assembly. The smaller yet also common type of smoke control system is what we call an engineered smoke control system. Again, as I referenced, this makes up about 15% of our marketplace. So not as big of a commercial market. However, they are very prevalent in public buildings, offices, theatrical environments, anywhere where you have places of public assembly. you may come across an engineered smoke control system. One of the more common control strategies for an engineered smoke control system is pressurization. So if we take a very simple example here where we have a common air handler and it's serving multiple floors in a building, and let's say a fire breaks out on one floor. Well, we certainly don't want the fire and the smoke that's associated with that fire to spread to other floors, causing potential danger to the occupants and also contaminating those floors with the smoke. So what we will do is, as the smoke is generated and the fire is detected in the building, to prevent it from spreading through the ductwork, we simply close off the supply duct to the area with the smoke. We open the return duct and send that to 100% exhaust. And then the areas that are not in a fire alarm condition, their exhaust or return dampers, the return dampers which are now part of the exhaust system, are closed. The supply dampers are open. We pressurize the spaces without the fire and smoke condition to prevent smoke from entering them. And of course, we are exhausting the smoke from the area with the fire alarm condition. The fire alarm space goes negative. The spaces without the fire and smoke go positive, and again, we prevent smoke migration into those areas that are not under a fire alarm condition. Another common smoke control strategy that's an engineered smoke control system is a stairwell pressurization system, and this can either use a series of motorized dampers or modulating dampers or a fan on a variable frequency drive and some pressure sensing. And what we do here is we make sure that there's enough pressure in the stairwell to prevent smoke from entering the stairwell from the spaces with the fire condition. And we also make sure that doors can be easily opened and closed so the occupants of that building can exit the building safely and easily and prevent any potential danger in the stairwell itself. Finally, we have atrium and other large space conditions where we simply want to exhaust the smoke from the area faster than it's generated. The intent is to prevent smoke from settling on the different levels of the building and once again preventing a safe means of egress for the occupants of that space. So we want to pull the smoke up through the atrium space and out the exhaust fan while allowing the occupants to leave the building safely. There are multiple different types of damper assemblies. There are fire dampers, smoke dampers, combination fire smoke dampers. Something that's very commonly seen in buildings are fire dampers, or what you might have heard called a fire curtain. These damper assemblies are regulated by Underwriters Laboratory 555. They simply do not have a motorized actuator on them, and they are generally normally open and they are closed by gravity. So they simply fall closed once a fire condition is detected. What's used to detect that fire condition is it's basically detected by temperature. And we have a fusible lead link in there. And as you can see, if you look closely, these lead links have different temperature ratings. So for example, say the temperature in this ductwork gets to or exceeds 165 degrees Fahrenheit. The lead link will melt, the fire damper will slam closed, and we will prevent the fire and smoke from spreading through the ductwork. Now these are not resettable, so what we'll have to do is someone will have to go back, locate the fire damper, and replace the fusible lead link to get the system back in operating condition. Then we have a smoke damper. So this is a damper that is connected to a duct detector of some sort, and it is regulated, of course, by UL 555S for smoke. There will be an actuator on smoke dampers in all cases. The majority of smoke dampers are normally open, and the actuator will spring closed. However, in some cases, especially in engineered smoke control systems, possibly like that atrium example we saw a few slides earlier, we can have normally open smoke dampers that spring closed simply based on the, normally closed fire smoke dampers that spring open based on the application and the ventilation strategy. You will find multi-section smoke dampers and combination fire smoke dampers as long as our jack shafts and our linkages are true and the damper functions properly. This will work just fine for all applications requiring larger fire smoke or smoke dampers. Generally with smoke dampers, they are two-position actuation. They are used for containment and zone smoke control. So not a whole lot of modulation with smoke dampers themselves. They are generally just used to open and close the dampers and contain smoke to specific areas where a fire alarm condition is detected. Then we also have the combination fire and smoke damper assembly. So now we're both looking for a smoke or duct detector alert that tells us, okay, we have smoke in our space or in our duct, and we also take into consideration temperature on the duct. So if we look at this damper assembly here, we can see the orange actuator on the bottom connected to the jack shaft of the damper, and then above it there's a small handy box with an extension ring on it, and there are two switches protruding from the face of that handy box. Those are high limit temperature sensors. Most likely one is rated for 165 degrees and the other likely rated for about 250 degrees. What will happen is those will sense temperature in the duct, and if there is for some reason no smoke or no smoke detected, but temperature reaches those higher limits, they will break power to that actuator and close the fire smoke damper assembly. Here we see a very, very basic drawing and how most combination fire smoke dampers are wired. On the right-hand side of the screen, we see our neutral or our common going to the actuator body. So we've got constant common or neutral to the actuator. Then either our 24 volts or 120 volts hot goes through the normally closed set of contacts, either at a relay or a duct detector, then through that 165-degree high limit switch I referenced. Once either the 165-degree high limit switch is opened or the duct detector relay contacts are open, we remove power from the actuator, and the actuator will close the fire smoke damper assembly. There are also potential auxiliary contacts that can either let an alarm system or fireman's override panel know the position of that damper. So you may not see auxiliary contacts in every case, but they are in some cases required for alarming and indication. What we see here is something a little more sophisticated. Now we're looking at a HOA switch from a firefighter smoke control system that is put in place to control a combination fire smoke damper assembly. In the off mode, power is removed and the fire smoke damper assembly is basically closed. So we remove power from the hot side, damper closes as if we were in a fire alarm condition. If we switch to auto, we are in normal fire smoke control operation. So our duct detector has a normally set of closed contacts. Power runs through those closed contacts. Then we run through two high limit switches in this case. The first being a 165-degree high limit switch. The second being a 250-degree safety switch. As long as all three of these switches are closed, or the set of contacts in these two switches are closed, the actuator will be in the open position. If the duct detector senses smoke, those contacts open, we will close the damper assembly. If we exceed 165 degrees Fahrenheit, the high limit switch will open, we will close the damper assembly. And of course, if we see temperatures at or above 250 degrees, the fire smoke damper assembly will close as well. When we go to the hand mode, this allows the firefighters to override the fire smoke damper assembly so that they can exhaust or maybe pressurize or make spaces negative or positive as needed. And basically the hand contact will override both the duct detector and the 165-degree high limit switch. However, it will not override the 250-degree high limit switch. If in fact we have 250-degree temperature present in the ductwork, we simply do not want that damper to be opened. That is a safety that's put in place to prevent any serious fires from spreading without our knowledge or without the HOA being in play. So Belimo simply makes fire smoke damper actuators. We sell our damper actuator product to OEM damper manufacturers, and we also sell them individually to contractors for installation and replacement purposes. They all have DC motors, low holding noise, very cool running motor at a very low current draw, so this makes our installation and our circuit sizing very favorable when we're doing new construction. Belimo has also developed a proportional fire smoke damper actuator, so this will allow you to have one damper assembly that can be used for modulation or balancing as well as fire smoke conditions. You may see these in pressurized floor cooling, if you have an economizer damper in a firewall, or again in that engineered smoke control application, stairwell pressurization I referenced a few slides earlier. Here we see a very basic drawing of how the fire smoke damper proportional actuator is wired up. We have our common going through our duct detector and our 165 high limit switch. If either of those break, of course power is removed from the actuator and it closes. We have constant 24 volts hot to the 2-wire, and then just like any other proportional actuator, whether you're using it for volume control on a damper, let's say, we have a 2 to 10 volt signal that simply modulates that damper open and closed, but the damper actuator is rated for fire smoke applications. So again, if our duct detector or a high limit switch open, we close the duct for the damper for fire alarm condition. We can also use the FSAFB24 as a balancing damper. So instead of having a fire smoke damper and a manual balancing damper, they can be combined into one damper assembly. And what we do is very simply, we have our 24 volt common going through a set of normally closed relay contacts. If for any reason we go into a fire alarm condition and now those contacts are broken, that will spring the damper closed. We have our number 2 wire, which is our hot, and that takes constant 24 volts to the number 2 wire for power to the actuator. And then we have our 3 wire, again, the modulating wire like we saw on the previous screen, to modulate the damper. But in this condition, if we have a need to override that actuator open, what we use here is a double pole, double throw relay. We run our signal wire through a normally closed set of contacts, and then we connect the signal wire to a normally open set of contacts connected to the 24 volt hot. If in fact we need to override this damper open, we fire that relay's coil, we break the normally closed contacts that provide the modulating signal to the actuator, and we simply send 24 volts to the 3 wire or the signal wire, driving that damper 100% open. All Belimo fire smoke dampers actuators are UL 2043 rated for flame spread above ceilings and below floors. There are often questions about Underwriter's Laboratory and can or can I not replace a fire smoke damper actuator on an existing fire smoke damper assembly. According to UL, as long as the dampers are replaced in accordance with the damper manufacturer's normal field servicing program, it is okay to put new fire smoke damper motors on existing fire smoke damper assemblies without replacing the entire damper assembly, which of course is a whole lot easier to replace a damper motor than to pull an entire damper assembly out of a wall. One thing Belimo has done regarding this fire smoke damper actuator replacement has put together a comprehensive list of retrofit instructions that you can find on our Belimo.us America's Fire Smoke portal. As you can see, we have step-by-step instructions for replacing fire smoke damper actuators on all fire smoke damper assemblies made by the major manufacturers of fire smoke damper assemblies. So, with all that said, that is the webinar on fire smoke dampers and combination fire smoke damper assemblies and applications. If there are any questions, I guess Mikhail will open up the floor to some questions for us.
Yes, thank you so much, Steve. That was great. So we do have a couple of questions coming through. If anyone had joined us midway through the presentation, now we're into our question and answer session in which you are able to type in your question. I will read them aloud and Steve will answer them as best as possible. If after the fact we shut down the webinar and you start thinking about a question that you didn't have when this session was occurring, you can email us at marketing@us.belimo.com. If you're interested in receiving a PDF version of this presentation, you can go ahead and email me as well, and I will get that out to you. And last but not least, just a friendly reminder that we do have a handout available for you to download. Okay, Steve, are you ready for that first question?
Sure am.
Okay, what is the most common smoke control strategy?
Well, as I referenced in one of the earlier slides in the presentation, most common smoke control strategy is what's called containment. and that is simply a fire smoke damper or combination fire smoke damper assembly connected to a duct detector or a fire alarm system, and it's used to contain smoke and fire to a specific room or area of a building.
Okay. Which is better, smoke detector, photoelectric or ionization type?
That's a difficult question for me to answer. Honestly, not being a manufacturer of duct detectors, that it's really more of an application thing. I see both used in different locations throughout my territory.
Okay. Next question. What is the most common smoke control strategy in a healthcare facility that is considered a high building? And this is in Canada.
Considered a high building, is it meaning a high-rise building? If that is the case, generally what I see most commonly is fire smoke dampers interlocked with the starters on large air handlers. So as the duct detectors in the areas being served by the air handler sense smoke, they break the contactor that controls the fan or the contractor on the VFD controlling the fan, and that in turn shuts all the fire smoke dampers closed in that application.
Okay, thank you for that. Oh, getting a lot of questions. Sorry, Steve. In
Okay.
In a dynamic HVAC system, what kind of actuator is better to use?
In a dynamic, could I get a little clarification on dynamic? Meaning, is this a variable air volume system? Is this a non-dedicated system where we are using an HVAC system to also do smoke control?
All right, so that's Robert. If you could just follow up with that question, and we're going to move on, and we'll come back. Is there any difference of testing between a normally open operation to a normally closed operation?
No, I don't believe there should be any difference in the testing for normally closed or normally open. It should all be predicated on cycles.
How is a damper position monitored? With damper end switches or an aux contact on the damper actuator?
Generally, it's depending on the code enforcement in the area. So Belimo fire smoke dampers actuators come with auxiliary contacts on the actuator itself, and in many locations the authority having jurisdiction will accept those contacts as monitoring points for the damper position. However, it's really something that needs to be addressed by the local code enforcement. I have come across locations where they did want physical end switches on the damper shafts themselves.
Okay. For fire and smoke dampers related to a smoke control system, what speed do you typically see specified?
Speed specified, that's a good question. Most commonly, the opening speed really is not a big deal, but it is the spring return speed that is the most common common speed that's referenced or taken into consideration when you're doing a fire control strategy, because you're just going to open for your normal conditions in most cases and either spring close when you start to see your fire alarm condition take place. So generally, I believe the most common speeds for the spring return are either going to be 25 seconds or less, 20 seconds or less, or 15 seconds or less, depending on the size of the damper.
Okay. Is it very common to have indicating lights associated with the dampers?
Again, more of a local code enforcement thing. I do know that here in Florida, it's common for us to have indicator lights, especially in hospitals, on the ceilings above where the fire smoke dampers are located for a simple visual inspection. And in some cases, of course, you will have indicator lights at the firefighter smoke override station as well.
What are the advantages and disadvantages to controlling the FSDs through the building automation system versus the fire alarm system?
Oh, that's a very good question. In some cases, building operators with larger buildings do prefer this, what we might call single seat control. So you can control and monitor both your HVAC and your fire alarm through one location. And this is especially relative if you have a non-dedicated system where you're using your fire smoke or you're using your HVAC for smoke control as well. One thing to keep in mind, if in fact this is going to be done, the building automation system's front end has to be UL listed for smoke and fire alarm control.
Okay. When retrofitting an existing smoke control actuator, where could we find information on the existing damper? That is, if it's retrofittable. Many of these dampers are very old.
Yep, that's a great question. You may find information on the inside of the damper, but I know that is very, very difficult to locate in some cases. And with time and wear and dust and intrusion, sometimes that information is hard to find. There is usually some sort of manufacturer's marking on the damper assembly itself, but that's generally difficult to locate. More oftentimes than not, it's on the inside of the damper. If you don't know what you're dealing with, and you can get some visual photographs specifically of the damper shaft and assembly as well as the existing actuator connection and actuator, you can send those to your local Belimo district sales manager, and he or she can help you figure out exactly what you're dealing with.
Okay. Can you retrofit a combo smoke fire damper to an existing manual volume damper?
If you make it a manual damper, it no longer is qualified to be a fire smoke damper.
Okay.
So it will work as a manual balancing or manual volume damper, but it's no longer a fire smoke damper.
Are the damper motors required to be wired into a UPS for the transfer to emergency power?
Generally, yes. Generally, all fire smoke damper actuators are either wired to emergency power or some sort of uninterruptible power supply. Really depends on the layout of the electrical in the building. In newer construction, such as hospital and schools where you have emergency circuit panels, your fire smoke damper actuators are fed from the emergency panels, which are backed up by the generator.
What is the difference between a smoke-rated actuator and a regular rated actuator?
There's several differences. A lot of it is temperature and torque rating. They go through different UL testing as well, but the biggest thing is temperature, torque, speed, things of that nature.
Okay. Do we need to install a smoke damper at the smoke partition, or can it be installed at a remote location, e.g. a unit feeding floors? A separate duct run is installed for each floor. Can the damper be installed at unit?
Generally, the smoke dampers are supposed to be installed at the partition.
Okay. And we have a couple more minutes. We have one more minute for a couple questions. So someone is asking, the fire and smoke selection at the Belimo Select Pro does not allow me to select dampers. It pops up. There's a pop-up window that sends me to Belimo website. How can I make the damper selection module to work?
You know, I have to be honest with you, Michaela. I don't know the answer to that question. Is that maybe something we could send to our Select Pro experts?
Absolutely. Al, we will take care of you. No worries on that. We'll get you the best answer possible. And last but not least, we're getting lots of questions. Okay, so just to wrap this up, this certification, there is no certification for this webinar. This is just a webinar we'd like to put on for our customers on different topics throughout the year. If you're looking for PDH credits, this unfortunately is not being offered for this webinar. Steve, I want to thank you very much for doing an excellent presentation. I know many of you have typed in questions that we did not get to answer, I don't want to hold up the line, but we will get back to you with answers to your questions. So just stay tuned. I want to thank you once again for participating in our Belimo customer webinars. I'm going to give you a little preview. Our next webinar is on the 3rd of August at 1 p.m. and it's going to be on Belimo Retrofit Solutions. Our Part 2 of the year calendar has not been posted, but will be posted shortly. But because you tuned in today, you found out that our next webinar will be on 3rd of August. So once again, Steve, thank you so much. Thank you everyone for participating, and we look forward to seeing you at our next webinar.
Thank you.